My topic is distributed matrix factorization with MapReduce. Um, so I mainly divide it into five aspects. Um, First one, background. Second one, main idea. And algorithm principle of matrix factorization and solutions for matrix factorization. And the last one, parallelization of matrix factorization. So the first one, background. That is the background of matrix factorization. um, a matrix calculation is an important step in many scientific calculations, and distributed matrix storage is the basis of distributed computing. According to different calculation requirements, it is necessary to build the matrix used for calculation and use the idea of MapReduce to map the calculation of the entire matrix into submatrix operations, so that in the calculation step of a matrix, each part of the matrix is different synchronously on the calculation unit, and finally reduce the results to get the calculation result. Such matrix block calculation has a good acceleration effect for large matrix operations, and whether it is common CUDA programming of GPU or common MPI programming of CPU, Hadoop or Spark programming, the key function of matrix block storage operation is required. So, in the word, there are two main aspects of distributed matrix factorization with MapReduce. The first one is use MapReduce to simplify the matrix calculation and get it faster. And the second one is use matrix storage and use distributed matrix storage. Let's get to the second part, the main idea of matrix factorization. So, take the more commonly used recommendation algorithm scenario as an example. User operation behavior can be transformed into the following user behavior matrix. Among them, RIG is the score of user I on target J. If it is implicit feedback, the value is 0 or 1. Here we mainly use display feedback, the user's real rating, to explain the matrix factorization algorithm. And the matrix factorization algorithm decomposes the user rating matrix into the product of two matrices, that is, R in multiple n equals U n multiple k times V k multiple m. Among them, U n multiple k represents user feature matrix, and V k multiple m represents the subject feature matrix. A user's score for a certain subject can be the product of the row corresponding to the matrix Un multiple k, the user's integer vector, and the column corresponding to the matrix Vk multiple m, the integer vector of the subject. With the user's rating of the subject matter, it is easy to make recommendations for user. Specifically, the following methods can be used to make recommendations for users. So first, multiply the user feature vector by the target feature matrix, and finally get the user score for each target. And after getting the user score on the subject, filter out the subject that the user has manipulated from the score. Sort the remaining subject scores in descending order and recommend top n to the user. So for the matrix factorization, the core idea is to decompose the user behavior matrix into the product of two low-rank matrices. And through the decomposition, we aimed the user and the target into the same k-dimensional vector space. K is generally small, tends to 100, and the inner product of the user vector and the target vector represents the user's preference for the target. Therefore, the matrix factorization algorithm is essentially an embedding method. And the purpose of matrix decomposition is to fill in the missing data element that users have not scored in the user behavior matrix through machine learning, and finally achieve the goal of making recommendations for users. And for the distributed part, it is shown from following four aspects. The first one is use MapReduce is map the calculation of the entire matrix into the sub matrix operations. And the second one, each part of the matrix is different synchronously on the calculation unit, and then reduce the result to get the calculation result. So use distributed programming, we can get good acceleration effect for large matrix operations. Next part, I will introduce algorithm principle of matrix factorization. Assuming that the user's rating matrix for the item is M, and the user factor matrix is U, and the item factor matrix V, the matrix decomposition algorithm can be expressed as M equals UV. Realize the matrix decomposition that is solve the optimization problem of the first formula. Due to the sparsity of the score matrix, in order to avoid overfitting, a regular term is usually added to the formula. That is shown as the second formula. Commonly used regular term is the second normal form, where lambda u represents the weight of the user model vector modulus, and lambda v represents the weight of the item model vector modulus. And part four, I will introduce some solutions for matrix factorization. So for the optimization problem, the previous PPT, there are really two solutions in engineering, SGD and ALS. So the first solution, SGD, when the termination conditions are not met, the bottom formula will be iterative calculated, and the termination conditions really is the converge of the loss function value. That is, the loss function values of the two iterations does not change much within a certain range, or the number of iterations is fixed. And the SGD method generally converges quickly, but in the case of massive data, a single machine cannot carry such a large amount of data. So the above iterative calculation cannot be completed on a single machine or in a short time. At this time, we can use the ALS method to solve. And the ALS method can be very easy to do distributed expansion. So for the ALS, the essence of the alternating descent method is to fix U so that the partition derivative of f with respect to v is equal to 0 and update v. And then fix v so that the partition derivative of f with respect to u is equal to 0. And update u, that is ALS. So let's come to the final part, the parallelization of matrix factorization. Usually we can use Hadoop technology to parallelize the matrix factorization algorithm. So we really modify update the specifications of the user factor model matrix and the item factor model matrix into the form of matrix multiplication, multiplication and division. So it can be seen from the update formula definition of the user factor model U and item factor model V that the realization of the matrix factorization algorithm focused on the realization of matrix multiplication. So, and there are 3 usually used methods to do the matrix multiplication in distributed server. So the first one, Hadoop implementation of inner product method. Matrix C equals A, B, the inner product of the left matrix row and the right matrix column. C matrix is M multiple N, and A is M multiple S, and B is S multiple N. This method is only very efficient when the right matrix B is a small matrix. So the second method, outer product method. It is calculated by the outer product of the left matrix column and the right matrix row. The maximum concurrency granularity achieved by MapReduce based on the outer product methods is S. And when the memory of the reduce node cannot store a row or a column of the left matrix and a column or row of the right matrix, the 2 methods mentioned above cannot effectively solve the problem. So at this time, it can be realized by the methods of block matrix, which is block inner product. The left matrix is divided into M1 multiple S1 equal size matrix, and the right matrix is divided into S1 multiple N1 equal size matrix for calculation. After block inner product, it will be calculated by inner product method. So that's all. Thank you.